Hi, good afternoon. This is Mrs. Jacobs, and I'll be doing GOMath, Grade 4, Chapter 2, Multiply by One-Digit Numbers. This lesson is 2.2 multiplication comparison problems. However, it's really a combination of lesson 2.1 and 2.2. And so this lesson will cover all the comparison problems in lesson 2.1 and 2.2. So the students will be introduced to multiplication comparison problems inside both of those lessons. So I am making this video to model and show how to solve 3 different comparison problems that were covered in lesson 2.1 and 2.2. So the learning target for today is I can model and solve comparison problems, and this is standard 4.OA.1. So in this video, I will teach you how to model and solve comparison problems. We will be introduced to 3 different scenarios or situations that are considered to be comparison problems. So I will show you the 3 different scenarios so that you can see how the wording of the questions change as well as how the models change. Make sure to pay attention to my modeling and how I take apart these types of problems. So you should be not only listening, but watching how I unpack and unlock the problems to help you with solving them. All right, the steps are the same. So in each of these models, you will hear me repeat the same steps over and over. However, the models will look different. So let's get started. First thing we're going to talk about is some of the vocabulary that's needed for this video, okay? And to understand how to solve comparison problems. First of all, this first 2 definitions were covered in my lesson 2.1, but however, I'm going to revisit them. You need to know a multiplication equation is a multiplication equation that has at least 2 factors, an equal sign, and a product. So my example here is 5 times 3 equals 15. So that is considered a multiplication equation. It has factors, multiplication symbol, an equal sign, and the product. Okay? Or for example, 2 times 2 times 1 equals 4. That's still a multiplication equation. It's just 3 factors. All right? The most important thing to remember when we're writing a multiplication equation is obviously you need multiplication symbols, and equation refers to equal sign, and you also need a product. All right, next word. Multiplication comparison. It is a multiplication sentence that uses the phrase times as many as or times as much as. I refer to it as the famous words, right? And why it's so important to know and recognize these phrases is that these are the phrases that we will look for when we're willing to make a model. Okay? So they're going to be really helpful to us. And the last word that we're going to talk about is the word variable, a letter that represents an unknown value. Okay, so I gave an example. 5 times 6 equals R. So the letter R is a variable. However, it stands for an unknown value, and it is our job to figure out what that value is. So if you know what 5 times 6 is, then you will know the value of R. So R equals 30. So you will see in this video me referring to some of these words. Okay? All right, so let's start with our first problem or first scenario. First thing we're going to do is go through a few things. First thing, you have to make sure that you read the problem from beginning to end Don't do any underlining. Don't do no circling. We're just going to read. Then after we read, okay, I'm going to take you through some questions we should ask ourselves. And we will do some underlining and crossing out and so forth. All right? So let's read it first. Nick has 10 baseball cards. John has 5 times as many baseball cards than Nick. How many baseball cards does John have? Draw a model and write an equation. So the biggest thing at first, the first step that we need to start thinking about is, since this is a comparison problem, and it's a multiplication comparison problem, doesn't always mean we're taking the two numbers and multiplying. All right, and this is the whole point of this video, is to show you that there will be situations where you cannot do that. All right, so we actually have to think about what is being compared in this problem. So I know that we're comparing the number of baseball cards Nick has compared to what John has. Right? So that's the comparison part. So you need to know what's being compared. So now that we know it's baseball cards, we have to know specifically it's Nick's baseball cards versus John's baseball cards, right? So that's the first thing we're going to do, is write that information out so we could get our model started. All right? So I'm going to write Nick in a second. All right, so I'm going to write Nick. Okay. Here's Nick, and we have John. Okay, so I'm going to write Nick and John, and I know it's baseball cards, so obviously when I answer my question, it will be in baseball cards, right? So now that I did the first step, is identify what's being compared, and we jot that down. Next, we're going to go to the sentence that helps us to get the model. Model is a drawing, right? So the sentence that helps us to draw a model or to get it going is the sentence that contains those famous words, the times as many. So we automatically are going to unlock this problem and take it apart, but we're going to take it apart in a sense that makes it useful to us. So we really need to draw a model. So the sentence that helps us to draw the model is the sentence that contains the times as many as. So here it's John has 5 times as many baseball cards than Nick. So John has 5 times more than Nick, right? So that tells me that since John has 5 times as many, John is going to get 5 bars or 5 boxes next to his name. Why? Because he's going to have 5 times the amount of Nick. Right? So I'm going to draw the 5 bars. 1, 2, 3, 4, 5. 5 bars next to John. Okay? And if he has 5 times as many, that means Nick only has 1. Okay? Nick has 1. So now I have a whole bunch of empty boxes, right? And what I'm going to do here is I'm going to cross out this sentence because we don't need it anymore and we took the information we had from it, right? And now it says Nick has 10 baseball cards. So Nick has 10. So right now Nick has an empty box. However, according to the word problem, Nick has 10 baseball cards. So in his box, he gets the value of 10 because we already know that. Okay? And now in a model, all the boxes have to have the same value. They have to be equal. And reason why this makes sense is if Nick has 10, John has 5 times as many. So each of these boxes have a value of 10, okay? And now this is our model. Now we have to write an equation, okay? What equation are we using to answer this question? How many baseball cards does John have? Well, when we look at our bar model, we see that John has 10 in each box, but he has 5 of them. So it'd be 10 times 5. So 10 times 1, 10 times 2, 10 times 3, 10 times 4, 10 times 5. 10 times 5 is 50. So John has 50 baseball cards. Okay, so John has 50 baseball cards. All right, so now we're going to look at another problem, and it's worded a little bit differently. Okay? Jackie and Morgan were saving money to buy a new phone. So far, Jackie has saved $120. This is 12 times as much money than Morgan has saved. How much money has Morgan saved so far? All right, so again, let's talk about the steps. First, we have to think about what's being compared, and we know it's money. Money's being compared, but whose money? Because we need to be very specific. So we have Jackie's money and Morgan's money. So that's what we write down. Jackie, Morgan. Okay. So now that we know what's being compared, we go to the sentence with the famous words, because that sentence is going to help us to draw the model. And that's the sentence that contains the time as much times as many. So I see this sentence. This is 12 times as much money than Morgan has saved. So my question is, who are we talking about when we're talking about this? So watch how I ask this. Who? Who has 12 times as much money than Morgan? Who has it? So who here will have 12 times as much money than Morgan? Well, it can't be Morgan, so it has to be the other person. So Jackie. So the this stands for Jackie, and this is really important. This is like a reading strategy, right? And we're trying to identify who the sentence is talking about, because that's very important for us. So now when I read this, it says, so far Jackie has saved $120. Jackie is 12 times as much money than Morgan. All right? So since it says that Jackie is 12 times, Jackie gets 12 bars. 12 times, 12 bars. Four, 5, 6, 7, 8, 9, 10, 11, 12. And that means Morgan is going to get 1 box, all right? So now that this sentence helped me to draw my boxes, I'm done with it. We're going to cross it out. And now we're going to look at the next piece of information that's available to us. So the piece that we didn't do, we're not ready to answer the question yet, is so far Jackie has saved $120. Now, we're referring to Jackie, okay, And we have to go, Jackie has saved $120. So when I look at my model, I go to Jackie's name. And it says she saved $120. But you have to be careful. I can't put 120 in each box, because if I did that, it would be 120, 120, 120, 120, 120, 120. And the sentence says she saved 120. So you can't put 120 in each box, because if you did that, she would have saved way more than $120. So what we're going to do is we're going to show that Jackie has saved $120 in total. So watch how we do that. To show that Jackie has saved $120, we're going to use a bracket. And let me show you what that looks like. This bracket shows me Jackie has saved a total of $120. Okay, so we're showing Jackie's total as a bracket that encloses all of her boxes. So that's very different than putting 120 in each box. And for those of you who thought you were supposed to do that, you really have to think if that makes sense. Especially when you say, ooh, 120, 120, 120, 120, 12 times. That's not going to show us $120. That's going to show us way more. So you always have to go back and ask yourself, does that make sense? So now we show a total that Jackie has saved $120. So that is gone. Now it says, how much money has Morgan saved so far? Well, it still can't answer this, because in order to answer this, we have to get another number involved. And right now, the only number is 120. So we're going to use Jackie's number of 120 to help us solve this problem. So watch how I do this. So now that there's a whole bunch of empty boxes, we're going to use a variable. Remember, a variable is a letter that stands for the unknown. Okay? And I'm going to use the letter R. So what I'm going to do is give every box the value of R. Now we don't know what R is, but we're just going to use a variable to help us get there. So I'm going to use R, and I'm going to keep on going, filling all my boxes with the letter R. Okay. So every box gets the same value, so every box is going to be an R. Now, when you look at this, you're like, Mrs. Jacobs, we still can't figure this out, because now we have a whole bunch of R's and there's still no other number. So watch me as I show you how we get this equation going, all right? So the model is here, but now we need some numbers, right? So watch how I do this. I'm only looking at Jackie. So we have 1 times R, 2 times R, 3 times R, 4 times R, 5 times R, 6 times R, 7 times R, 8 times R, 9 times R, 10 times R, 11 times R, 12 times R. So I write 12 times R, and then it says equal. Well, I know what all these R's are equal to. It's equal to $120. So now we have to figure out what the letter R represents, what its value is. So 12 times what number will give me 120? And this is your basic facts, right? So I know 12 times 10 will give me 100. So R equals 10. Now some students, the most common mistake is to think we're done, but we're not. Because now that we have a value for the letter R, we have to go back to our model and make every R we see the value of 10. So I'm going to do that in a different color so we could see that. So I'm going to go back, and I can't fit the value inside the box, so neatly you could do it above it. 10, 10, and I'm going to go make all these R's 10. All right, and let's not forget that Morgan also has a box with an R. So that gets a 10 too, because all of them have the same value. Every R is equal to 10. So now when I'm looking at this, okay, I have finished my model. I replaced all my R's with a value of 10. Now I can move forward and try to answer the question. Question says, how much money has Morgan saved so far? So in this question, we're looking at Morgan. So we're going to use our model here to answer questions. So Morgan has $10 next to her name. Okay, we know Jackie is 120. Morgan only has saved $10. So far, Morgan, so far Morgan has saved $10. And I just want to see if my answer makes sense. So let's just go back to the problem here. It says Jackie has saved $120. Yep, Jackie has saved $120. Jackie's number is 12 times as many than Morgan. Yes, because, right, this is my checking. 12 times 10 equals 120. So yes, so we now know for sure that my answer is correct, because 12 times 10 equals 120. So Jackie has saved $120. Unfortunately, Morgan has only saved 10. All right, $10. Okay. So it's very important when you see the word this. I'm going to tell you that's a common one. This. Not only the word this, but you might see the words such as he. I know not in this case, but he or she. And we need to identify. So if you see a problem with he or she or it, right? You need to figure out what they're referring to. Who is the he? Who is the she? What is the it, right? And just like we did here with the word this. So keep that in mind when we're trying to problem solve. All right, so this is our third scenario or situation, all right? And it looks familiar to the one just before. The only thing that's going to change a little bit, especially for part A, is where we draw the bracket, okay? So I'm going to take you through the steps, all right? So first I'm going to read it. Samantha and Christina went apple picking. After apple picking, they counted up all their apples. Together, they picked a total of 24 apples. Samantha picked 5 times as many apples than Christina. Part A. How many apples did Samantha pick? Part B. How many more apples did Samantha pick than Christina? All right, so since this is a two-part question, obviously I can't answer part B yet. I have to work with part A. But before I even can answer part A, I must get my problem started by asking what is actually being compared. So since we are talking about apple picking, right, they counted up all their apples, and so we're comparing Samantha's apples that she has picked and Christina's, right? So we're comparing the amount of apples Samantha and Christina picked. So in order to do this, we're going to have to write their names. I'm just going to shorten Sam, okay, and Chris for now, all right? So Sam and Chris, all right? And now that I identified what's being compared, I automatically go to the sentence. Nothing changes. These steps are the same. the sentence that helps me to draw my bars, which is the sentence that contains the times as many phrase or times as much as, right? So in reading this question, I see the sentence that says Samantha picked 5 times as many apples than Christina. So Samantha's the one who picked more, all right? But Samantha gets the 5 bars because she picked 5 times as many. So I'm going to draw my 5 bars. 1, 2, 3, 4, 5. And now cross out this sentence because this sentence helped me to draw my bars and helped me to tell me how many and where I'm drawing it, right? So next I have to think of what piece of information is left over. And that's the one that has a number or a value we didn't use yet. So I'm rereading this sentence, okay? And I'm just putting one box next to Chris because Sam has 5 times as many. That means Chris has to have 1, right? For someone to have 5 times as many. And now I'm looking and it says together. So I'm just going to underline that, all right? Together, and then we'll talk about what that means. Together, they picked a total of 24 apples, okay? Now, it's not just Samantha's total, and it's just not Christina's total. It's a total that they did together. So to show the together, that they did a total of 24 apples together, the bracket cannot go over just Samantha's name, and the bracket can't go over just Christina's boxes, right? To show that it's together, the bracket's going to be drawn to the side like this. Right? And this shows that together, now you have to imagine, I'm just going to draw this, it's like an imaginary line, right? That they're referring together is everything inside here, right? So it's not just one person's, it's both of them together. But both of them together collected 24 or picked 24 apples, right? So that's how I represent the together, with a bracket off to the side showing both names included, right? So now I'm done with that. Together they picked a total of 24 apples. Now basically the problem will be solved the same way, all right? It's just that the bracket moved, all right? So now you're going to say, oh, I still have a whole bunch of empty boxes. And then we're going to say, okay, we're going to use a variable to represent the unknown value. So let's use, let's see, A for apples, right? So we'll do A, 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 A. All right, so now we have a whole bunch of A's inside this bracket. But this time, we're not only counting just Samantha's A's, but you got to include Christina's as well. Why? Because it says together, and the bracket shows that I have to count up all the A's inside there. So when I'm counting, I have 1, 2, 3, 4, 5, 6. There are 6 A's in here. Why? Because it's Samantha and Christina. Okay, so we have 6. So we're going to write 6 times A equals, of course, the total is 24. And then A will be equal to 4. So now it's my job to go to every A and make it the value of 4. So I'm just going to write on top of the boxes right now, 4. Okay. Now since they both picked a total of 24, we really need to find out, well, how much did they do each? I know how much they did together. It's 24. Now, it's our job to figure out, well, how many apples did Sam pick and how many apples did Christina pick, right? So when I'm looking at this, I'm going to write an equation to help me figure out the total for Sam. So when I look at just Sam, I have 4, 1, 2, 3, 4, 5 times, right? So there's 1 4, 2 4s, 3 4s, 4 4s, 5 4s. So we're going to do 4 times 5. So 4 times 1, 4 times 2, 4 times 3, 4 times 4, 4 times 5. 4 times 5 is 20. And we're going to circle Sam's total. So Sam, right, her equation would be 4 times 5 equals 20. So Sam has picked 20 apples. And then Christina, when I go next to Christina, I said she did 4 times 1. She only has one box. So 4 times 1 equals 4. And we circle her total. So even though they collected 24 apples together, individually, Samantha did 20 and Christina did 4. But if I add them together, 20 plus 4 equals 24. And just to check my work off to the side, right, I'm going to add Samantha's apples and Christina's apples. And together, it's 24. So that is correct. All right? So please make sure that your work is detailed and we're writing equations and drawing the models correctly. That's really the most important part. And it's really taking your time to take apart and unlock the problem. Okay. Now we're not done here because I still didn't answer the question. How many apples did Samantha pick? So now when I go to my model, I only need Samantha's. And I see that I circled her total, which helps so I can identify it really quick, is Samantha collected 20 apples. So my would be Sam, picked, sorry, not collected. Sam picked 20 apples. Okay. Now if we look at part B is saying how many more apples did Samantha pick than Christina? Now, this is not a times as many question, but this is asking you to answer it using the model that you have drawn. So your model, we can ask many questions about someone's model. So looking at the model, now that we have totals, we have a Sam total and a Christina total, we can answer further questions. So how many more apples did Sam pick than Christina? So many more, my M&M strategy, M&M is subtraction, okay? And I am subtracting because we're, again, looking to find the difference between Samantha's apples she picked and Christina's apples she picked, right? So how many more apples did Samantha pick? So I'm subtracting. So first I need Samantha's total, which is 20. And Christina's total, which is 4. Make sure we're lining it up in the ones place. And if I have 0, I can't take 4 away. So I'm going to regroup. I'm going to cross out the 2, make it a 1, and make my 0 a 10. 10 take away 4 is 6. 1 to take away nothing is 1. So Samantha, or Sam, has picked 16 more apples than Christina. All right. So when solving comparison problems, there are certain words that we really need to look for. Okay? And in this problem, the biggest word here we had to understand is together, right? And they picked a total, right? That's very important because that has really shown us where we need to draw the bracket. And if it's together, a total that is done together, the bracket needs to go off to the side. Okay? If it's only one person or one thing or one object that has a total, then the bracket goes over that person or object's name. Okay? So these are the three different scenarios or three different situations that we have been introduced to in 2.1 and 2.2. And of course, it's going to take time with the drawing of the models, but most importantly is unpacking them and realizing how many bars are being drawn, who we're drawing it next to, and always asking ourselves what we're doing, does this make sense, right? And using the information that's given and crossing it out when we have used it and we're done with it. Okay? So thank you for joining me, and these are the three different ways that you can solve a comparison problem because there's three different scenarios going on. Now it's going to be your job in the future to solve these when they're all mixed up. So you can have a paper with all these three different scenarios, and you're going to have to know which way or how you're going to solve them. All right? So thanks for joining. Enjoy your day.